Okay, so we're picking up from the last video, just our partial fraction example. The algebra is going to take us a little while, so I didn't want to get too carried away there. So here's our initial example that we're working with. We have x squared plus 2x minus 1 in the numerator, and in the denominator we have three linear factors. And from our previous video, we know that to write this out in terms of your constants, we have a over x plus b over 2x minus 1. That's a minus 2x minus 1. Sorry about the mess. Plus c over x plus 2. Now I should say that sometimes it's not clear if you have a linear term or a quadratic term. So for example, how would you deal with something like 3 divided by x squared times x minus 1? How would we rewrite that in partial fraction form? Well, you can actually treat x squared as either an irreducible quadratic, or you could treat it as a double linear root. So one way to write it would be a over x plus b over x squared plus c over x minus 1. So this is treating this as a repeated, or sorry, as a repeated linear root. And so if I want to treat that as a quadratic, I would say ax plus b divided by x squared plus c over x squared, x minus 1. And so do you see here that these two expressions are actually the same thing, these two? And so these are equivalent to each other. Okay, that was just a side note because sometimes that pops up. In this case, we have three distinct linear factors, so we have three distinct expressions over there. And now the question is, how do you solve for a, b, and c? Well, the way you do it is you clear the fractions by multiplying both sides. Multiply both sides by the denominator. So if we do that, on this side we just get x squared plus 2x minus 1. And on this side, don't multiply the denominator out. Leave it in factored form. Because if you multiply this times this, right, the x's will cancel. And so you'll just be left with a times 2x minus 1 times x plus 2 plus b. And then the 2x minus 1s would cancel. So you'd be left with x times x plus 2 plus c. And then the x plus 2's would cancel, and you'd be left with x times 2x minus 1. Good. Now when you look at this equation, it looks like there are a, b, c, and x as the unknowns, but x is not an unknown in this expression. This should be true for all x. Okay, so therefore one technique for solving for a, b, and c is to pick three nice values of x. Pick nice values of x. So in this example, what are my nice values of x? Well, they're values of x that would zero out some of these terms, right? So x equals 0 would be a clear one. Maybe x equals 1/2 would be another one. And then x equals minus 2 would be the third, right? So if x is equal to 0, we would have minus 1 equals, what's that, minus 2a. And so a is equal to 1/2. If x is equal to 1/2, then your a term is 0, your c term is 0. So this is b times 1/2 times 1/2 plus 2 is 5/2. And that's equal to 1/4 plus 1 minus 1 1/4. Okay, let's see, so that means that 1/4 is equal to 5b over 4. B is equal to 1/5, I guess. Huh? And then similarly for c, if you plug in x equals minus 2, what do we get? 4 minus 1 is equal to 0 plus 0. And then c times minus 2. Sorry about that. Minus 4 minus 1 is minus 5. Looks like c is equal to 1/10, huh? Good. And so we found a, b, and c, and so therefore, whoops, that's a minus 1/10. Now I wanted to just point out that there is a different way of doing this. That it's better if you have like quadratic terms in the denominator so that they're not nice values of x to use. Okay, so let's look at that. Write it over here. Start a new page. So in this case, we have x squared plus 2x minus 1 is equal to a times 2x minus 1 times x plus 2 plus b times x plus 2 plus c times x times 2x minus 1. Okay, so we want to solve for a, b, and c. And the way to do it in this situation is that we're going to compare coefficients. That is, I have one polynomial of degree 2 over here and a polynomial of degree 2 over here. So therefore, the coefficient in front of the x squared on this side, which is 1, is going to be equal to the coefficient of x squared on this side, which I need to compute. Similarly, the coefficient of x on this side has to be equal to the coefficient of x on this side when you compute it. Similarly, the constant over here must be equal to the constant over here. And so let's start off with x squared and see where we go with this. So for the x squared terms, on the left we have a 1. And what are the coefficients of x squared on the right? Well, if I were to multiply this out, I would have 2x squared here and times an a, so that would be a 2a for the first term. Notice that I'm not writing down the x squared. Here I'm going to have just bx squared, so that's going to be the b. And then on this side I'm going to have 2cx squared, so that would give me a 2c. Good. So how about the x terms? That one's going to be kind of harder to do here, but we'll have a 2 on this side. And then what will the x terms be on this side? Well, the x terms on this side are coming from the 2 times 2x or minus x. Okay, so that's going to be 4x minus x, 3x, 3a. Is that going to be 3a? I think that's right. Plus, in this case, the only way we're going to get an x term out of this is 2x, so that's going to be plus 2b. Okay, how about this side? Looks like we're going to get a minus c there. Oops, sorry about that. That'll give us our x on that side. Good. And then finally we have our constant terms. We have a constant of minus 1 on this side. Do we have any constants on this side? No constants here. No constants here. The only constant here is going to be coming from the minus 2a, and so I'll write minus 2a on this side. Good. Now this looks complicated, but we are immediately able to get a right off the bat, right? So a is equal to 1/2. Once you've solved it here, you can plug in 1/2 into these two equations, and then you have 2 equations and 2 unknowns for your b and c. That's not too hard to solve. I don't want to bring in too many questions of algebra, but you might just do a substitution, right? Solve the system by substitution for the x and ax squared. And you might try that for practice, because in the last page, right, we actually got our a, b, and there's our c, there's our b, and there's our a. So you can double check that you get those, that b is equal to 1/5 and c is minus 1/10. Good. And just to be clear, right, where we started with was x squared plus 2x minus 1 over x times 2x minus 1 times x plus 2 is equal to, I'm going to plug in my a, b, and c now. A was 1/2 times 1 over x plus 1/5 times 1 over 2x minus 1 plus, minus 1/10 times our 1 over x plus 2. Good. And now we can integrate these directly, right? 1/2 natural log of x. I like to use the absolute values there until I know if x is going to be positive or negative. Okay, this one is just slightly tricky. You have to be careful because it's not just the natural log of 2x minus 1. You have to have a 1/2. So you're going to end up with a 1/10 times the natural log of 2x minus 1. It's not that tricky. Minus 1/10 times the natural log of x plus 2. Good. Plus c. Good. And there you go. We've integrated. Okay, I should say maybe the integral of this thing dx is equal to that. Okay. Wow, we spent another 10 minutes on some algebra. Oh well, I think it was worthwhile to practice. I'm sure you got it down now. So go forth and practice some more. I'll see you later.